Section 2.4 on complex numbers. So we're going to talk about the imaginary unit I. So there's two rules that we need to know when we're dealing with imaginary numbers. First is that the I equals the square root of -1. So anytime you see a negative underneath the radical, that's going to come out of the radical as an I. And the other thing is anytime you see an I squared, we're going to use the fact that I squared equals -1. So these are the two things that we're going to do with the imaginary number is anytime you see -1 underneath the radical, bring it outside as an I, or anytime you see an I squared, change it to a -1. So the standard form of an imaginary number is a plus bi, and that just means you write the real number first and then the imaginary part at the end. A conjugate of an imaginary number is kind of like its opposite. So if an imaginary number is a plus bi, its conjugate is a minus bi. You only change the sign of the imaginary part of the number. Okay, and then when you're taking the square root of a negative number, like I was talking about a second ago, the square root of a negative number is going to equal I times the square root of that number. So if it's the square root of 4, then you can just go ahead and take the square root of 4. But if it's not a number that has a perfect square, then you'll need to simplify and factor that out. Just remember, a negative underneath the radical is the same as an I on the outside. Okay, so in example 1, we're going to simplify the square root of -56 and then write it in standard form. So first thing, the negative underneath the radical is going to come out as an I, so I times the square root of 56. Then I need to factor the square root of 56. So I know that 2 goes into 56 28 times, 2 goes into 28 14 times, and 2 into 14 7 times. So everything on the outside of my factors here are all prime numbers. Because it's the square root, I need pairs of numbers. So I have a pair of 2's. Nothing else on the outside has a pair, so those leftovers have to stay inside. And the pair can come outside of the radical as one of those numbers. So that means this is going to be 2 times the I that was already on the outside times the square root of 2 times 7 on the inside will be 14. So 2i times the square root of 14 is in standard form. Sometimes in your textbook you'll see the I at the very end, so it'll be 2 times the square root of 14, then the I. Sometimes people get confused and think that the I is underneath the radical, so we just go ahead and write it in front of the square root. Okay, number 2, same thing. Let's simplify and write in standard form. So the first thing I notice here with -6i plus I squared is that I squared can be changed to -1. So this is going to be -6i minus 1. Then I need to rearrange it to put it in standard form. You always put the real number first and then the imaginary part. So this is going to be -1 minus 6i. Okay, number 3, same thing here, we're going to simplify. So I have 8 minus I minus 4 minus I. So I'm just subtracting these two imaginary numbers. So we're going to start with the real numbers. 8 minus 4 is just 4. Then I would do the imaginary numbers. So -I minus a -I can change to -I plus I, which would cancel out 0 i's. So we don't have to write any of those down, so the answer is just going to be 4 for here because the i's canceled out. So it's just like adding and subtracting and collecting like terms. You can imagine that the I is just a variable, and then we have those two special rules that if there's a negative under the square root, it comes out as an I, or I squared, change it to -1. Okay, same thing with this one. We're going to add or subtract these numbers. But before I can add or subtract, I need to simplify the radicals. So the -2 is going to stay the same, but the square root of -8 can be simplified. So we know that the I is going to come outside, and then I have to simplify the square root of 8. Well, I know that the square root of 8 is 2 times the square root of 2. So that means that square root of negative 8 is 2I square root 2. Same thing for the second parenthesis. The 5 is going to stay, but I need to simplify the square root of negative 50. So the negative will come out as an I. The square root of 50 simplifies to 5 square root 2. So it's going to be negative 5I square root 2. So now I'm just adding and subtracting to collect like terms. So negative 2 plus 5 is going to equal 3. Then I can add the imaginary numbers. Now the only time I can add square roots is when the number underneath the square root is the same. So since these are both a square root of 2, then I can just add or subtract the number in front. So 2I minus 5I would be negative 3I square root 2. Okay, so that's as simple as it gets. We have our real number first and then our imaginary number at the end. Okay, now in example 5, we're going to simplify by multiplying an imaginary number. So I have a 6I outside of the parentheses being multiplied times 5 minus 2I. So we're just going to distribute. 6I times 5 will be 30I. Then when I do 6I times negative 2I, that'll give me negative 12I squared. Then if there's anything I need to simplify, I go ahead and do that. So I notice I squared changes to a negative 1. So that's going to be 30I minus 12 times negative 1, which will change to a positive 12. So that will be 12 plus 30I is what it simplifies to. Remember, your real number goes first, then the imaginary number. Okay, number 6, we have a binomial squared plus another binomial squared. So I'm going to rewrite those as 2 plus 3i times 2 plus 3i plus 2 minus 3i times 2 minus 3i. So I'm going to FOIL the first two together. So first would be 2 times 2 is 4. Outside, 2 times 3i is 6i. Inside, 3i times 2 is 6i. And last, 3i times 3i is 9i squared. Okay, now let's multiply the second pair. So first, 2 times 2 is 4. Outside, 2 times negative 3i is negative 6i. Inside, negative 3i times 2 is negative 6i. And last, negative 3i times negative 3i will be plus 9i squared. So let's go through and collect like terms and see what else we can simplify. So I see 4 plus 4 is my only real number, so that's going to be 8. Then I look at all of my i's, just the 6 i's in there, and those are all going to cancel. So I'll have 12i minus 12i, and those go away. And then I have 9i squared and another 9i squared, which will give me 18i squared. Then I need to change the I squared to negative 1. So this is going to be 8 plus 18 times negative 1, which will be 8 minus 18, which is negative 10. Okay, now on number 7, they want us to write the conjugate of this imaginary number and then multiply by it. Well, before I can write the conjugate, I actually need to simplify this imaginary number. So negative 1 minus the square root of negative 5 can be changed to negative 1 minus I square root 5. Okay, so if this is my imaginary number, its conjugate is the same thing, just the middle sign is changed. Only the imaginary number part is changed. So that's going to be negative 1 plus I square root 5. So now we're going to multiply those together by FOILing. Okay, so first, negative 1 times negative 1 will be a positive 1. Outside, negative 1 times I square root 5 will be negative I square root 5. Inside, negative I square root 5 times negative 1 will be plus I square root 5. Last, negative I square root 5 times I square root 5 will be negative I squared times 5. Remember, when you multiply a square root times itself, it cancels out. Or you can think of it, square root of 5 times square root of 5 is the square root of 25, and the square root of 25 is 5. So notice here when I'm going to simplify, let's start on the right hand side. 5 times negative I squared, I know that I squared is going to become a negative 1. So it's really going to be a negative 1 times 5 will be a positive 5. Then I'll look at the middle two terms, and they're the same except one is positive, one is negative. So those are actually going to cancel out. And then I have a 1 at the very beginning. So now 1 plus 5 equals 6. So it actually works out every time you multiply an imaginary number times its conjugate that the i's are going to cancel out. So that's very beneficial for us when we're working division problems with imaginary numbers in the denominator. So for example, number 8. I have 3 plus I divided by 3 minus I. So it's considered improper to have imaginary numbers in the denominator. So to get rid of the imaginary numbers, we're going to multiply by the conjugate of the denominator on the bottom, and whatever I do to the bottom, I have to do to the top. So we're going to FOIL the top and FOIL the bottom, and then simplify. So when I FOIL the top, first, 3 times 3 is 9. Outside will be 3i. Inside 3i. And last, I squared. When I FOIL the bottom, first, 3 times 3 will be 9. Outside, 3i. Inside, negative 3i. And last, negative I squared. So then let's go through and simplify the top and bottom. So on the top, I squared is going to change to a negative 1. So that's 9 minus 1 is 8 plus 6 i's on the top. On the bottom, the middle two terms are going to cancel, which is what I wanted. And then I've got the negative I squared on the end. I squared is negative 1, so that really that's a plus 1. 10 plus 1 at the bottom, or 9 plus 1 will be 10. Okay, so now we're going to simplify our fraction. And what I would do is you can either split up your fraction or you can find something on top to factor out. So I know a 2 will factor out of the top, and that'll give me 4 plus 3i all over 10. Now the 2 on the top and the 10 on the bottom can be reduced. 2 goes into 10 5 times. So this would be 4 plus 3i over 5. Or you can also split it up and say 4 over 5 plus 3 over 5i. Technically, this is the correct answer because we had a plus bi. And the first way, it's not separated into two different terms. But I'll take either one of these. Okay, number 9, same thing. We're going to simplify each parenthesis, and then we will wind up multiplying these together. So on number 9, we're going to simplify each parenthesis. So I want to do 3 plus, and I'm going to change the square root of negative 5 to 3 plus I times the square root of 5. And then in the second parenthesis, I'm going to change 7 minus the square root of negative 10 to 7 minus I square root 10. Now we will FOIL these two together. So first, 3 times 7 is 21. Outside, 3 times negative I square root 10 will be negative 3I square root 10. Inside, I square root 5 times 7 will be 7I square root 5. And last, I square root 5 times negative I square root 10 will be negative I squared square root 50. So now we need to go through and simplify anything else that we can and collect like terms. So the first 3 terms I can't do anything with. 21 is going to stay. The square root of 10 is simplified. Square root of 5 is simplified. I can't add those two together because they're different square roots. The only thing I can simplify is that last term. So the square root of 50 can be simplified, and we'll do that in a second. But negative I squared changes to negative 1, so negative negative turns into a positive. So now let's simplify the square root of 50. So the square root of 50 is going to turn out to be 5 square root 2. So then I look to see if there's any terms that I can add with 5 square root 2. Again, all of these have different numbers underneath the radical, so I can't put any of them together. So I'm going to rearrange and start with the real numbers first without i's, and then put anything with an I at the end. So I'm going to put 21 plus 5 square root of 2 minus 3i square root 10 plus 7i square root 5. All of these are different terms. There's nothing that I can add together or subtract or simplify. This is as simple as this one gets. Okay, now on number 10, we're going to use the quadratic formula to solve this trinomial. So when we get to a certain point in this problem, we're going to see why this has to do with imaginary numbers. So we're going to start by plugging in the coefficients in this trinomial to the quadratic formula. So this is going to be x equals negative 16 plus or minus the square root of 16 squared minus 4 times 17, all over 2 times 4. So I'm going to simplify underneath the radical first. So that's going to be negative 16 plus or minus, underneath the radical simplifies to negative 16 all over 8. Well, I know that when I take the square root of a negative, that imaginary number I is going to come out. And then when I take the square root of 16, that's going to be 4. So this is going to be negative 16 plus or minus 4i all over 8. So then I'm going to split this up and reduce the fraction. I'm going to say negative 16 over 8 plus or minus 4 over 8i. And I can reduce these two fractions. So negative 16 over 8 is negative 2, plus or minus 4 over 8 reduces to 1/2 I. So this is in standard form because it's a plus bi, and I've got them in the correct order. So these two answers would be the solution to the quadratic equation.